Well, as I say, my name is Mike Williams. I've been working for Ericsson for the last 42 years, which I think earns me the title of a grumpy old man. I'll be retiring in August this year, which has the great advantage in a company that you can say and do exactly what you want, because there's no point in trying to fire you because you'll go anyway. So there's some advantages with age, not many, but some. I was going to talk about what are my experiences of the last 20 years in managing organizations which produce large volumes of software. So I think that large volumes of software are actually not a very good thing, but unfortunately they do exist. And it's very difficult to see what we would do without them. I think most software projects are small. That 4 people is a fairly sort of typical sort of software project. I guess that most of you in this room do small projects, but a few projects are very large, several hundred people. In fact, some of the projects that I've been working with have had over 500 people involved. Well, I ask a show of hands, how many people have actually worked in a project with more than 10 people here? That's actually surprisingly much. How many people have worked in a project with more than 100 people? We're getting there. And how many people have worked in a project with more than 500 people? Well, I'm just amazed. 2 of you. I'll have to talk to you afterwards to see if you agree with what I have to say. Why are projects large? Well, what makes them large? Well, basically, the main reason for things being large is that the problems we have to solve are very large problems. The things I worked on the last 10 years have been mobile radio base stations. Can anyone guess how many millions of lines of code there are in a base station? Either a CDMA or a 3G or a 4G base station. Would anyone guess 1 million lines of code? 2 million? 3 million?
Less than 1.
Oh, you get in there, halfway in between. Something like 6 million lines of code, which is an awful lot of code. And it requires an awful lot of people working on them. And why are they large? Because basically the hardware we use is special purpose. That the streams of data which come down from the antenna, the aerial, are large. We're talking about gigabits per second, which have to be analyzed in special purpose DSPs. These monsters are programmed in DSP-C, which is a strange dialect of C. And you really don't have much choice except using DSP-C for that sort of thing, because you simply just have to crunch the data which gets through. There's nothing else you can do about it. But on top of that, we have a lot of people called operators. Now, we like the operators because they give us money. We hate the operators because they tell us what they want us to deliver. They want to be able to manage their sort of several hundreds, often even thousands of base stations from one single central point. Now, that makes life difficult. They also have a certain amount of problem with the software in their base stations. They want to be able to upgrade their software in very strange places. That a lot of base stations are sort of very inaccessible. In certain countries, base stations are inaccessible because you have to have armed guards to take you to the places where the base stations are. Otherwise, you'll get murdered on the way there. Not a sort of good idea. Other base stations are difficult to get at because the copper thieves will be there and try and steal the parts of it. And we have to sort of guard them with sort of mad dogs and this sort of thing, sort of keep people away from them. So upgrading a base station has to be done remotely, and it has to work. Most of the software that we write for these things is written from scratch. That I sometimes think that the standards which are made for writing base stations are actually made to make programming base stations difficult. We don't want small companies to be able to take us over, and therefore we make the standards incredibly complicated so no one else can do it. I think that's a bit of a sort of naive approach, but there's a lot of stuff which has to be done. Signal processing, protocol handling, traffic setter, resource handling, adaptation to low-level operating systems. To make life difficult, we tend to use weird operating systems. You may have vaguely heard of an operating system called OSE Delta. No one else uses it. I think Nokia uses it as well, actually, but we're fairly sort of unique. So to make life difficult, of course, if you use that, it makes life even more hard because there are no proper tools. We're actually moving everything over to Linux nowadays, so that makes things a bit easier. Another problem is that we have a lot of hard real time. The data which comes down from the antenna, you just cannot sort of wait a bit. And if you miss a bit of data, then you miss a bit of speech, and people don't like it. It's even data is actually better than speech, because data, the TCP/IP protocols and this sort of thing will clear it up for you. But people don't like sort of talking when it goes tick, tick, tick in the middle or something like that. It's sort of, people find it somewhat irritating. Another problem is that people's lives depend upon our systems. If you have an accident on the highway, you want to be able to phone 911 or 112 or 999, depending on what country you're in, and you want to know 100% that it works. You don't want a sort of a little pause because someone is busy upgrading the system just then, and nor do you want the thing to crash. Mobile systems are a lot easier than wireline systems because people expect things to crash from time to time. You drive through areas with no coverage, or you drive under bridges and things break. So that when things break, well, people are a little bit more tolerant than they are with wireline systems. But nevertheless, you have to remain a certain standard in your traffic. So that when we make changes, we have to make changes on the fly with as little outages as we possibly can have. And our upgrades must work. We cannot upgrade a base station and then find we have to send a little man out on a bicycle in China somewhere to repair it. Operators just don't like that. So we have millions of lines of code, and we have hundreds of people working on it. And this requires an organization. The organizations which I managed was only part. I used to say that I was a manager of about 500 people at one stage. And people said, gosh, you must be a big manager and I'm a big guy. And I said, no, as far as Ericsson is concerned, I'm a sort of middle-of-the-range, low-line manager, because that's the sort of scale of the sort of problem. And an organization that has to be run. Now, I found, actually a few months ago, a very interesting bit of research which came from, you can read the URL a bit later. It came from the Virginia Tech Carolina Research Institute, where they actually did experiments on groups of people. And they found that if you put groups of people, and I regret to say that I hope there are not any women here, because it was found that it went worse for women than it did for men, that you have a dumbing down effect of the more people that you have sitting together in a meeting. And this is actually, has all sorts of implications, and nothing else, that jury services are a bad idea, because juries are actually less intelligent than individual people. However, I'm not talking about legalities now, I'm talking about sort of programmers. And putting a lot of programmers in a room together is apparently an idea to make them produce worse code than if they work individually. I think the fact that going to meetings makes you stupid is nothing really sort of surprising, nothing that you all knew. We all knew about that anyway. But, oh, well, going to meetings is nice. You can have sort of donuts and coffee and this sort of thing and talk to your friends and don't have to do any real work. But in point of fact, it does make you stupid. So this is a problem. We have an organization of several hundred people who are trying to do things, and we're putting them in meeting rooms and trying to stop them being stupid. Well, how do you get around it? How do you get around the dumbing down effect of putting a lot of people in a room and hoping that they sort of will do something sensible? How do you get around the fact that you have managers that say, do it this way, and the programmers say, no, don't want to? There are problems. Well, this is really how we made software. And I think you all recognize that we have some form of requirement. Sometimes the requirements are actually written down on bits of paper, sometimes they're in your head, sometimes they're a standard. And then we design a little bit at a time, a design increment. We then test and verify what we've designed and find that it doesn't work. And when we've got it right, we correct it, and we go around that cycle until we get something which works reasonably well. As I think a fairly normal way of doing it. Now, the point I'm making here is it's very important that you can go around that cycle very, very fast. That as time has gone on, we found all sorts of obstacles that we didn't know existed began to exist. That we used to use a version handling system called ClearCase, which I'm sure some of you have come across. Unfortunately, ClearCase slows down that loop, because every time you check something out, it takes time. And just a few minutes checking things out at one period of time will actually infect the whole cycle, which is why we're slowly moving from things like ClearCase to things like Git instead, which are a lot faster. That if your tests go slowly, then you're going to have to wait, and well, everyone likes drinking cups of coffee, but if you want to, testing is important that it goes fairly fast. Building integration is important that it goes fast. So everything which delays going around that cycle is a bad idea. Now that's an ideal picture of an ideal world. Life isn't really like that. It's like this. That I have a lot of the cycles going on the outside with a lot of different teams, and a lot of parts developed independently, and then I get in the requirement, and I have to have a big team at the end of the day that put everything together and make everything work. And this here is the problem. There is where you have the dumbing down effect. That's where you get people working together, and you get people having to coordinate. That the teams on the left have to deliver at the same time and produce things which get into there. So the whole idea of isn't that popular nowadays with Agile and Scrum and everything like that, everyone keeps on talking about. It all works very well in the small teams, but it simply doesn't work when you put everything together, because you simply have to put everything together. You have to coordinate, and as soon as you start coordinating large numbers of people, you get a non-agile situation. So what do you do about it? The hard thing is that features are not independent of each other. I can give you a very simple example from the radio field. A feature we have there is to change the propagation characteristics of a base station. We have a little motor on the top of the aerials, which means you can tilt them. And you can tilt them backwards and forwards, and you think, well, that's not a hard job to have a little synchronous motor and a little feedback loop and work out what angle you're pointing at. Anyone should be able to do that. But unfortunately, if you do that, you actually change the characteristics of your cell. So that actually means that the feature of tilting the aerial actually means you have to reparameterize your cell so that you know what coverage you've got. A simple thing like that means that one team who is writing the software for tilting the aerial has to coordinate with the software of the team that's doing cell control. That's life. Another problem is that at the end of the day, we can't have people writing parts of the software for our base station or whatever it is in one language and other people writing in other languages. Certainly we can do operation and maintenance in one language, and we can do DSP programming in another, and we can do traffic control in a third language. But that's okay. But we can't simply have different parts of traffic control done in different languages, simply because at one stage we have to move people from one team to another, and we have to have common architectural principles. So what we do is we do need an organization to do that, but we need to minimize the dumbing down effect of having people working together. Very few top-level architects are necessary. We have to make sure the top-level architects that we actually have are clever people that understand what they're doing. And this means that we have to have people that have worked with this sort of system for years. They've had to work with the system maybe for 10, 15 years to know what's going on. And hiring people like that is difficult because we have to sort of pay them a lot to make sure that they actually stay with us and give them all sorts of shares and options and all sorts of things to keep them. That's difficult. For us as engineers, we all understand how important it is to have these clever people working on that. But unfortunately, as you get to our personnel and HR departments, they don't understand why we need to pay people so much to do this sort of thing. You get the whole politics for a whole organization, which come out in that sort of thing. It has to be overcome. Key aspects, what do we need? We need clever people. Obviously, if you're going to design a big system, everyone at every level has to be reasonably clever. You can't have poor programmers, and that's a problem. If I'm going to hire 500 people to produce a system, it's going to be very, very costly for me to hire 500 of the top-notch programmers. It's just simply not going to be possible. So I have to accept the fact that I have a varying level of skill level of various people writing software. We have to have an organization. When organizations, as soon as you start organizations, you start talking about management hierarchies and people that think they're better than other people and that sort of thing. We have to have a way of working which works. That's a principle. We have to have a documented way of working. This is how all these people work together. And there's nothing that people really hate more than being regimented against processes and all the rest of it. People want to work in different ways. And we have to have a technology at the end of the day which works. Now, in the whole of industry, you'll find people that will talk about all of these. You'll talk about some people know how to recruit clever people. Some people know how to build organizations. Some people now will talk about ways of working. Nowadays, if you want to make money, you write books about Scrum and Agile and extreme programming. That's the best way of making money nowadays. Far better. There's more money in that than there is in technology. I think Francesco's in the wrong branch, you know. Sort of, on the other hand, at the bottom level is technology, and people tend to forget technology. I hear time and time again, it doesn't really matter what sort of programmers I employ, as long as I have, what sort of technology I use, as long as I have good technology. Well, that is the sort of greatest bullshit you can hear from many people. I mean, if that was true, we'd all go back to programming in assembly language, and we'd not forget about everything else. Technology is absolutely crucial. And this is why I think Erlang and OTP is a very good technology for this sort of thing. We use it in certain parts of our system. In Ericsson, we use all sorts of technology. And Erlang OTP is used in some places. Not as much as I'd like to see it used. I think there are always the problems that people have various ideas, and we've inherited a lot of systems. We've bought up a lot of systems. But we do use it. And why does it affect that little loop I was talking about? Well, strangely enough, one of the things which people don't think about is the ability of loading code into a running system. That actually makes incremental programming a lot easier. And it makes it easier simply because we don't have any build times. If I'm testing something and it doesn't work and I can rewrite my code and load it into the system, I can do that in a matter of seconds. If I have a large system built with C or C++ or Java, and I have to write make and then wait for 15 minutes for the whole thing to recompile and reload, that costs me time. So being able to load code incrementally minimizes test times and it minimizes build times, and that's very important. It's also very easy to debug and tracing, because so much dynamic information is always available. You can always find out where things crash very easily and very fast. It's a lot easier than, for example, a large system built with C++, which you largely probably have had to turn off the -G option in your compiler, simply because it generated too much code to fit into your memory. So when things crash, what you have to do is recompile with the G option, put in debugging printouts and all the rest of it. In Erlang, you don't need to do that. And that is another thing. Finding a bug when the thing's crashed or when things have gone wrong, you can do that very fast. And another reason, of course, is the compact code. Erlang is incredibly compact code. We reckoned once upon a time that it's about a factor 4 shorter than C++ code, on a factor 6 shorter than normal C code, straight up and down. And because code is smaller, you can navigate your way through it easier, and you need significantly fewer people. As far as I work with, there are some aspects which are more important. The fact that I can isolate errors and I can isolate hardware failures and software failures and recover from them fast is very important. The error handling things, which I've actually was one of the people behind that back in about 1992, that is very important in our systems, simply because we can actually recover from errors very fast, keep things up and running. Another thing which people don't really realize, when Francesco was talking about evening classes in Erlang, you actually learn Erlang very fast. Erlang is very simple. It's a lot simpler than C++. It's a lot simpler than Java. It's a smaller language, easier to understand. And, you know, people will say, well, if it's that easy, it can't be very powerful. Well, the reverse is true. It's actually more powerful. It's difficult. If you want to learn, I think the difficult bits about Erlang is not actually the language. The difficult bits is about OTP and how everything works together and how everything fits together and how to build systems. That's where you land into it. I think Erlang you can learn in a couple of days. Learning OTP and how everything works around it, well, I think it takes you a few months to be sort of really up and running and going fast. But I think that's very true. If you would start learning Java from scratch, I think you'd find the same problems there. You have the same problems of looking at all the classes you need to learn and how everything works. So if you want to do anything, you know, start learning Erlang, you think, gosh, that's easy. Then you say, oh gosh, I've got to learn this OTP stuff, that's hard. You can concentrate on developing software, not fighting the language, which I think is important. That Okay, I must admit, it does have a bizarre syntax. That there were reasons for that. I think Robert just escaped out of the door there, so he didn't want to really explain that. Okay, that was the first part of my talk. What's happened in my background, what I think about developing large systems. I gave part of the same talk here that I'm going to give now in London. And this is the sort of fact that if you become an Erlang programmer and you think you're very good at it, what should you not test, tell your manager about Erlang? What's the difficult bit? The first part is that software development is an art, not a science. People talk about software engineering. Well, that's a load of bullshit. It's not engineering. The largest way you write software is trial and error, and we all know that. It starts off from I write code and I put it into the in an editor or whatever. I mean, some people use bizarre systems like Eclipse for writing code. I don't understand why. But I even found someone writing code using VI the other day. That was really bizarre. I think that sort of it's a trial and error process. All methods, all formal methods for looking at code have always failed. That formal proof has failed. People like learning this. You learn about this in universities, and you learn about it in college. You learn about formalism. Again, total failure, totally useless. Forget it all. Software developers have almost sort of religious beliefs in their languages and the way of working, which editor to use, which programming language to use. And so software development is an art. It's not a science. But unfortunately, we have managers who come from another part of the world. They have a Tayloristic view of the world. They think about software factories. I've always thought software factories is a wonderful idea. The first row writes the assignments, the second row writes the if statements, the third row writes the code. And in a company very close to me, which I will not mention because it would be a bit embarrassing. On the other hand, it doesn't matter because it doesn't matter if they fire me just now because I'm going to retire soon. We actually had someone from the personnel department that coined this wonderful idea. He said, well, look, that we're active in all sorts of corners of the world. When people are sort of waking up in the United States, people are going to bed in Europe. So they could hand over the code they just developed in Europe to the United States. And of course, when people are sort of going to bed in the United States, people are waking up in China. So they can hand over their code. And this bloke actually thought you could actually develop code this way. It's really true. Amazing. So people have really weird ideas about the way you develop software, especially if you don't do it. So basically, my message here is, for God's sake, don't tell your manager, the pointy-head manager, that developing software is trial and error. Trial and error doesn't sound sort of good. So tell them it's very scientific and you're very clever. That disadvantages. Another problem that you have is, does anyone know Professor Brainstorm, by the way? There's a wonderful book about that with pictures from here. Well, very few, not very well known. A lot of people have been indoctrinated in the ideas of object-oriented programming. Everything has to be object-oriented. The number of people have asked me, how do you write object-oriented programs in Erlang? Has been large, and my always answer is, you don't, and please don't. And then those people either say, oh, that was interesting, or they sort of go away and shake their head, he's nuts, can't be done. So a lot of managers think that you should do everything in an object-oriented way, and the sort of funky programming languages of single assignments and the bizarre syntax, watch out for them. So the answer to this question is that you tell them that Erlang is actually used in banking. Now that used to be a good thing to say, because until the crash of Lehman Brothers a few years ago. But I don't think we were responsible for that. Banking is solid. People believe in banking software. So that if you have people, pointy-headed managers that think that you're doing it the wrong way, point out banking, that's good. That calms down a lot of people. Another problem is easy to learn. Now that is a problem. If it's easy to learn, why should I pay you more for learning it? It's actually a heck of a sight easier than C or C++. Nice little example at the bottom there. I equals 10, I equals j equals I plus I. Does anyone know what the answer to that is, whether the answer is actually I should be 20 or 21? The strange thing is, in actually C, that is undefined. And being undefined, you never know what's going to happen. And so that's why a lot of software works in one compiler, doesn't work in another. It's not much of a problem in C, since everyone uses GCC, and most compilers are based on GCC. But that's interesting that C is a mess as far as that's concerned. So the best thing you can say is that, yes, it's hard to learn, but it'll make me very much more productive. Don't tell people it's easy. Pretend it's hard. But hard things, you get paid for doing hard things. You don't get paid for doing difficult things. Now, this is an interesting thing. I've come across this many times. It's communism. It's open source. I don't know. There's an easy answer to this one. If you have a pointy-head manager who says that it's open source and that's communism and not good, you ask him what compiler he uses. Now, if the boss says he doesn't know, then that's all right, because he doesn't know what a compiler is. No problems. You can get away with that. But if you say GCC, you can say, yeah, we use that. That's open source as well. Problem there. Never mind. That can get around that one. Easy to interface to other languages. Now, that also is a problem, that managers have friends that work for companies that develop all sorts of weird softwares. They develop databases and they develop all sorts of GUI tools and all the rest of it. And because they've got friends in different companies that would do that sort of thing, they think they should use their components. Oh, my friend Joe over there, or my friend Fred over there, he's got this wonderful system. Can't you integrate into that? Or Oracle produced this wonderful database. Can't we use Oracle databases in our system? That would be a lot easier than using Winesia or something like that. So you get this thing that if you say it is easy to interface to other languages, people will want you to interface it to other languages and other products. If you say it's hard, they'll say, well, we can't use that because it's hard. So this is a difficult one. Whatever you say that you get it wrong, you have to play this one by ear. I don't have some answer saying this to this one. All I can say is that you're in for trouble in this respect. That take it easy. This is the classical one. That about 10 years ago, I was talking to a researcher from a manager of a research group of a company which had a 3-letter acronym beginning with I, and the second letter was B in Paris. The third one, you can guess what it was. And I said to him, well, it's 10 times easier than writing software in C or something like that. And this man, he was French, and he spoke like this. I will not try and imitate him. And he said, well, look, I'm a manager of 10 people. And he said that if what you say is true, that I won't need those 10 people, and what's worse, I'd have to do all the work myself. So, Brooks' law, adding manpower to a late software project makes it later, is still very true. That doing things which seem to be too easy means that managers lose status, and managers largely throughout the world get paid in direct proportion to the number of people that they manage. That's why I don't manage anyone nowadays, and I'm absolutely practically broke. Last slide, more or less last slide. This is my view of the world. I'm sure you wouldn't agree that once upon a time we had assembly language. And then someone came along and invented Pascal. Pascal was actually quite nice, but unfortunately no one used it, and it had awful compilers and went very slowly. That after Pascal, Koenig and Ritchie invented C++. Oh, sorry, C, not C++. And it's great. I like C. C allows you to do things without having to go into assembly language. If you're careful, you can do things which are reasonably portable. You can write virtual machines for languages like Java and Erlang and all sorts of things. That C is great. At the same time as that C was being developed, there were actually other languages being developed, like ML was being developed at Bell Labs, and later on we've seen languages like Haskell being developed. We've seen OCaml being developed. At the same time, some idiot went and invented C++ at the middle. Now, I just don't understand why they did it. It was completely, utterly unnecessary. If you want to do the low-level things and you need speed, use C. If you want to do things which are efficient and which are easy to program and you don't require an awful lot of capacity, well, you've got Haskell, you've got Erlang. I'm not saying you have to use Erlang for everything. Use Haskell for, if you want to write a compiler, use Haskell for goodness sake. It's a lot easier. It's just the best language for doing it. That C++ and Java are an unnecessary step in human evolution and should have never been avoided. Okay, I think using Erlang is a good idea, but if you have an application for which Erlang is suitable, and I'm not claiming that Erlang is suitable for everything. I have had people that say, well, if Erlang's so great, why don't I use it for programming DSPs? And I say, well, that's not quite the problem. There are reasons for not doing that. But new approaches will always meet opposition from pointy-head managers. It's always going to happen, and you have to know it's going to happen. And having seen the number of people in this room, I feel a certain confidence now that I can retire happily and sort of grow tomatoes and forget about programming and see that it'll all happen by itself, which makes me very pleased. So good luck to you all. Thank you.